Chapter 5, Section 3 is about solving a system of equations graphically. The document that I've prepared has a few hiccups, and I'm trying to produce videos on a regular basis, and so I've decided to work through this particular section by just copying and pasting a rectangular coordinate system in for every problem. So the first problem that I'd like to graph by solving a system of equations graphically is question number 1, which reads x plus y equals 5 and 2x plus y equals 7. So what we need to do is we need to graph both of these equations. There's two options for this first equation. It's so simple. It's in standard form. It's got x and y on the left and a constant on the right. So if I wanted to avoid slope-intercept form for that one, I could say to myself, hey, if x was 0, if x was nothing, what would I have to add to it in order to get 5? And I'd have to add 5 to that. Or what if x was 1? What would I have to add to 1 in order to get 5? And you know you'd have to add 4 to that. Or if x was 2, I'd have to add 3. And I can just create a table of values for that one. So x is 0, I don't go anywhere in this direction, I go up 5. X is 1, I go to the right 4. X is 2, I go to up 3. I have a feeling I just said that last one backwards. I go to the right 1 and up 4. This one I go to the right 2 and up 3. I'd go to the right 2, 3 and up 2, right 4 and up 1, and finally I could go to the right 5 and not move in the y direction at all. And I can graph the line that goes through all of these. That would be amazing if somehow it kind of turned out straight. That's not bad. I'm not impressed, but I could graph it on my graphing calculator as well. Let's treat the next one by slope-intercept form. So let's subtract 2x from both sides. So I have y equals on the left because the x's are gone, and then I have a negative 2x and a positive 7. So I know then that the slope of this line is a negative 2, which I'm going to write as a negative 2 over 1, and the y-intercept is 0, 7. So I'm going to go here and go up 7 and put in the y-intercept. Then the slope of this line, it says in the y direction, my change in y should be to go down 2 and then go to the right a positive 1. So from this y-intercept, I'm going to go down 2 into the right 1. Down 2 into the right 1. Oh, look, that's where they overlap. Down 2 into the right 1. Down 2 into the right 1. Down 2 into the right 1. I'm going to go ahead now and draw my straight line through all of these, hopefully. And I wish to share with you that the solution of a system of equations is where the graph of that system intersects. In this case, that ordered pair is where x is 3, nope, backwards, where x is 2 and y is equal to 3. So let's go back into the original system. The original system was x plus y equals 7. So 5, geez, I don't know what's going on here. I saw that 7. So x plus y equals 5. And 2 plus 3 is equal to 5. That checks. The next equation was 2x plus y equals 7. And I want to know if I put a 2 in for x and a 3 in for 7, if by order of operations, if I have a true statement. And if I have a true statement in both equations, I know I've performed this calculation correctly. Okay, the next page. Let's see if I can get some graph paper here. Good. So question number 2 is to graph y equals a negative 1/4 x plus 1 and 2y equals x minus 4. On the same set of rectangular coordinate system, the first one's all set to go. The y-intercept is a positive 1. So here's my y-axis. I put that dot down. The slope of this equation is to go in the y direction down 1, and then in the x direction a positive 4. So from here I'll go down 1 and to the right 4. Down 1 and to the right 4. If I wanted to make the 1 positive and the 4 negative from the y-intercept, I could have gone up 1 and to the left 4. Up 1 and to the left 4. And I'm going to connect those dots. Not bad. And then let's do the next equation. So this one's not y equals something with x and a constant. It's 2y equals. So I'm going to divide both sides by 2. This x has a 1 in front of it right now, and I'm going to divide that by 2. I'll divide the 4 by 2. And now I have y equals 1/2 x. And then this 4 divided by 2 is 2. That's why you have to divide the 2 by both terms over here. And so the y-intercept for this one is a -2. And then because the slope is 1/2 and it's positive, I'm going to go up 1 and to the right 2. I'm going to go up 1 and to the right 2. Oh, look, that's the spot. Up 1 and to the right 2. Up 1 and to the right 2. Up 1 and to the right 2. I could go down 1 and to the left 2 because that'd be a negative divided by a negative. I'm going to connect those dots. Oops. Oh my, that's a problem. I think I got it right back where it was supposed to be, so I think I'm all set. So I'll connect those dots, and the solution to this system is where the intersection is of those two lines graphed. And to me, that looks like that's where x is 4 and y is 0. And so let's go into the original equation and let's check those two solutions. So the original equation was y equals a -1/4 times whatever x is. Well, x is 4. And then plus 1. So a -1/4 times 4 is a -1. And you add 1 to that. And is that equal to 0? Yes, it is. So it checks. The other original equation was 2y equals x minus 4. So if I plug in for y a value of 0, and then I plug in for x a value of 4, is 0 equal to 0? Yes, it is, and I know I found my correct solution. Finally, let's do this on our graphing calculator. So I want to move the calculator over a little bit. So I have to hit my y equals key. My calculator is stalled here. Okay, I got my calculator to work. So I'm putting in a -1/4, then x plus 1. And then the other equation in slope-intercept form, because remember this reads y equals, not 2y equals. So in this case, it's 1/2 x minus 2. I've got to look at my window and see if my window is in standard form. So x values go from a -10 to a +10, and y values go from a -10 to a +10. That's a good window for a non-story problem. And then I'm going to hit my graph key, and I'm going to watch those two lines show up. We're going to try to compare it to our graph that we just got. And you see that spot right there? Remember our answer was 4, 0? Don't forget, you can replay this process. To find the intersection point of two lines when you've graphed, you can go to this calc feature on your calculator. So you go second, calc, and you tell it you want to find the intersection point. So you can either arrow down to 5, or you can hit the number 5, and then it says, hey Pat, do you want to use equation y1, which is a -1/4 x plus 1, as your first curve? And I'm going to hit enter. And that will be my way of saying yes. Now it says, hey Pat, do you want to use 1/2 x minus 2? And it says, hey, that's the second curve. Pat, do you want to use it? I'm hitting this red enter button right now. And then it says, hey Pat, do you want me to guess where these two lines intersect? And I'm going to hit enter for a third time. And it takes me to the solution for x, which was 4 comma 0, in case it was hard for me to see and my graph was somewhat imperfect. So remember, that's what my graphs look by hand. That was my solution, but I just got it on my graphing calculator as well. We'll come back in our next segment and do this a little bit more. You might go ahead and practice a little bit.